to let me get started and share some screens. Let me make sure I pick the right one so you don't see all the other mess I have going on. Everyone see a terminal? Hopefully. I'm just going to go ahead and assume that you do. Before I go too far, I want to give you all a couple options. So I'm going to do a talk today where I debug some applications using Linkerd in a Kubernetes cluster. So what I'm going to pass out here is a couple publicly accessible websites that you can take a look at, and you can see if you can debug Emojivoto or Booksapp before I do. So feel free to ignore me and do that, or follow along, and let's get started. So just to kick off, we have an application. It's our very important voting service where we decide what emoji is best. So go ahead, pick one, view the current leaderboard. We see there's been a lot of votes, so it's obviously a pretty big deal, but fairly well distributed between our icons. But I'm getting reports from someone that it's not working quite right, and I don't know why, because everything kind of looks up. So let's do some debugging. Folks in the backstage or general, if you could put in the chat how you feel about the size of the text, that would go a long way. And thank you so much. So we're going to start, right? I'm just looking at my Kubernetes environment, and let's get some notes. So right now I'm running an in-memory cluster on my environment. I've got the one component, and it seems to be healthy, so that's good. So Kubernetes is all right. Let's just check the state of my service mesh with the Linkerd CLI. So I'm going to run through a bunch of tests to validate that this is in a good state. Looks like, hold on, I've got my handy dandy laser pointer. One more. There we go. Looks like all our status checks are good. So Linkerd is healthy. My app seems to be healthy. So let's use Linkerd to narrow this down a little bit. So you can do this via the dashboard or via the CLI. I'm going to do it via the CLI, and then we're going to pop into the dashboard and see some of what we're doing here. So I'm going to start. I'm going to use the Linkerd visualization extension to give me a sense of, by namespace, how are we doing in our key golden metrics about this application. Right now, I want to be clear here. This Emojivoto application has not been specially instrumented to work with my service mesh. I have not built in any metrics or monitoring into my app. All the data that we're going to see about this environment is data that the service mesh generates for you automatically without any changes to your application code. So we kick off. I can see that I've got some namespaces. I've got Booksapp, Emojivoto, Linkerd Viz, or Linkerd and Linkerd Viz. The key things I'm seeing here are, of that namespace, how many of the pods in that namespace are part of the mesh? That is, they have the Linkerd 2 proxy, our very small proxy written in Rust, running beside them. So all the pods and all my namespaces are meshed, so that's good. I can see a success rate that is problematic, right? So that is, of the calls that are going on in my environment, what percentage of those are returning a successful status, whether it's a gRPC status code or an HCP success response, right? I'm seeing in Emojivoto, 95% are successful, whereas in all namespaces, it should be 100%. I shouldn't be seeing these failures. I can also see the saturation at the time, as well as the latency by latency bucket, right? So we're going to go ahead and debug and figure out what's wrong with Emojivoto. So let's join me on this journey, or again, go to that link that I sent at the beginning. Let me just make sure that no one's saying anything weird in the chat. Yep, go ahead and link that dashboard.civo.59s.io to go and solve this in the dashboard. So I'm going to go now look at the deployments in my Emojivoto namespace and just see the statistics there. Once again, I'm seeing the same basic information, but now narrowed down inside the namespace to a certain set of deployments. So of my components here, I've got a vote bot, a web service, a voting service, and an emoji service. And we're actually just going to pop into the dashboard and see what that looks like. So if I go here and I go into my namespace, I can see a little graph at the top any second now. There we go. A little graph at the top that shows me how these components are talking to one another, right? So it's something that you can't see as easily with the CLI, obviously. But once again, looks like web and voting are having problems. Web's the front service, or the first service that's getting hit as part of the traffic coming in here. So let's go and take a look. What I want to do now is I want to see inside web what paths in my application are being explored, and what do I know about it, right? Because I want to see what's wrong with web, right? Because it's starting to see problems. So how do we get this fixed? So what I'm looking at here is there's a lot of text on the screen, so I'm going to try and make this a little bit simpler. The source is what pod is a given call coming from, a given call from one application to another on a path inside their API. So what pod is it coming from? What pod is it going to? What was the method? If I scroll over to the right, what actual call is being exercised within the API? And then how many have I seen? What's the response time and what's the success rate? So I'm looking, right, I should expect that calls from web to emoji are successful, because again, I saw that the emoji voto wasn't having any issue, or the emoji component of my app wasn't having any issues. But web to voting is having some problems. So if we scroll over here, web to voting, we see that, exploring this general API vote is only hitting an 85% success rate, and hitting the voting service and going to vote donut is 0% successful. So if you go to that emoji voto app that I put in the chat at the beginning, go vote for donut, you'll see that something is wrong. So already here, I've got a sense of what's going wrong, but we want to dig a little deeper. So it's one thing to know, okay, there's something wrong with voting for donuts. Even though donuts are the best, they're not getting their proper representation in our application. So let's go look at voting, right, and make sure that we can confirm our finding here. So now, once again, right, I see the source. Now for our voting service, right, if we remember from our little graph, our voting service is kind of a dead end in the path, right? So we go from VoteBot to web and either emoji or voting, right? So voting's not calling to anyone else. And we look at our terminal and we see everything's coming from the web pod to the voting pod. Okay. We can see what API calls, what API paths are being hit and what the success rate is. And then eventually, if we wait here long enough, we're going to see that sometimes donut is being voted on and it's not succeeding. There we go. Phew. So if we go back, we've got vote donut and a 0% success rate. And now, even though, we've tried to vote for donuts 3 times, 5 times, 6, thanks. Anybody who's voting on it, appreciate it. That voting is not working correctly. Great. So that's cool, right? So I'm like now totally sure, totally sure that I know my problem. But let's actually gather some information that we can use to send over to our application developers, right? So I'm not the application team. I'm the platform engineer. I'm responsible for this environment. So I want to give them the information so that they can go solve this thing as quickly as possible. So I'm going to use Linkerd's functionality to do a tap, right? And the topic of the title of the talk is tap, right? How do we diagnose our apps with Linkerd? And tap is a vital part of that, right? So tap will allow me to look at the calls from the web deployment to the voting deployment, right? And right now I'm just going to look at the base path here. I'm setting it to less so we can see some stuff. So there's a lot going on, right, in terms of calls in my environment, right? And I want to look for donuts. Next, come on, buddy. You got to be in here somewhere. I just never seem to get this working right. I want to look for calls to donut. You really? Thank you. So I want to look for donut. And I'm having a ton of trouble getting less to work here. So we're just going to quit out and we're going to refine my query and look for what's happening with the donut. So I'm going to do that same tap command where I get I get the live traffic between my components, right? But now I'm going to narrow down my search string from the base path inside the API, which is everything, over to the actual voting for donut. And we'll see what calls are coming in, and what's happening with them. So here, right, I've got a request information, I've got source information, destination information. Yes, it's TLS because if you're using Linkerd, every connection is MTLS every single time. I can see the method. There we go. I can see the method and I can see where it's going to, right? And I also get the HTTP status code is 200. So this looks successful from an HTTP perspective. But when I dig in a little bit deeper, the gRPC status code is unknown, which sounds like it just doesn't know what's going on, but that's unknown error in gRPC. So this is our application throwing a gRPC error, which Linkerd is detecting, telling us is a problem. And now, I've got some details I can send my developers, and they're ready to go fix emoji Voto. Yeah, but wait, there's more. Doing my wait, who's that dude? The Slapchop guy. Doing my best Slapchop. We're going to take the output, and instead of just seeing that little text string, let's get some JSON output so that we can get a lot more details. Now I can save this off to a log. Tells me everything I could want to know and a lot that I don't particularly care about this interaction between my applications. Save this off. I give you the API path. I give you some examples of the metadata around the calls between your components. And you as a developer now have all the ammunition you need to go figure out the problem inside your application code. And there's no arguing, hey, is this the service mesh? Is this the platform? Is this my downstream app? Right? We can see where the problem is. So that's solving emoji Voto's problem, right? So here I'm done with my original goal. And where am I at on time? 55. All right, sweet. So I still have a little bit. This is good, but we could solve it faster next time, right? So if you go look at the environment, right, and you go into voting, right? So it's cool to see the live calls, right? But what you're at the mercy of here is what comes through as you're watching, right? Or we could tell Linkerd, hey, listen, Linkerd, this is how our API works. I want you to store metrics and store data about these individual routes, and I want you to display them in a way that makes sense to me. So this is the default generic storing of data, but we're going to improve that using service profiles. So service profile is a way, this is one of Linkerd's very few custom resource definitions. Now, to be clear, you can use the Linkerd service mesh in your environment without having to use any custom resources. So your application that works in Kubernetes continues to work in Linkerd natively with some enhancements that it didn't have before. But we now want to teach our mesh something about in this case, our gRPC application. So I'm going to use Linkerd and I'm going to run the Linkerd profile command. And I'm going to look at the protobuf file for emoji Voto. So that's this API definition file, tells gRPC applications how to talk to each other. And I'm going to build out a service profile for the emoji service. What we create is a new custom object for Linkerd. It's a service profile. We give basically a definition of all the routes and what things are safe to do with them, right? So here I can begin applying this, right? So I can create this file. I can send it over to kubectl apply, and I'll create my service profile. Do it again for the voting service. Right, so that's good for our protobuf files and the apps that we have it. But in our case, web service, it doesn't have a Swagger file. It doesn't have a protobuf file. It's just kind of a very simple web API that we wrote specifically for the demo application. So what I'm going to do is I'm going to create a profile, but I'm going to do it just by telling Linkerd to watch the traffic that's coming in and use that information to create a profile of it. So let's do that. So we've got 10 seconds of me tap dancing here while it goes and views what calls are coming into web over the last 10 seconds. and then uses those to build a service profile, which it just finished creating. Let's go check out our dashboard. So excuse me, this is going to be small. Sorry about that, but I'll fix that. Or well, it doesn't really matter. You're just seeing a launch of the dashboard. I don't need you. Sorry, a lot going on here. Here I've got my other in-memory Linkerd instance. Now I can look at Emojivoto, and what you're going to see on this instance that you won't see on yours is if I go into web right now, I can go to route metrics and I can see what does it know now about the particular API calls, right? If I want to build in retries or I want to build in timeouts or anything like that, this is where I set it up, right? Is inside these service profiles. That makes sense? Cool. Now let's go to the second half. So that was debugging Emojivoto. So that's the core of the demo, and this is how we debug an application with Linkerd. Beyond that, what I want to show you is how do we go beyond debugging using service profiles? How do we debug fast there? And then beyond that, how do we actually solve our problem? So I'm going to start. So I ran this command, and I'm actually going to need to make it a little bit smaller. So I ran this command, which is basically instead of that thing I saw about give me the stats by deployment or namespace or whatever it may be, right? I'm going to actually ask for the routes, right? Just like we saw from that back tab. What are the routes in our environment for this books application, which is another one you can look at in that terminal that I sent. So here's books app. We can see that, posting to /books seems to be failing about half the time. That sucks. Posting for a particular book ID in an edit also seems to fail about half the time, but our latency looks good. So, what's going on? We've got some issues that we want to solve. So now let's go and actually let me step back and stop rushing for a minute. It's worth it to look at the structure of the books application, right? So with Emojivoto, we had a traffic generator, a web front end, and then two backends that the traffic ended at the individual backend. Here, right, what we have is traffic, a web front end, and two backends that talk to each other, right? So there's a little bit more complex stuff in here about the interactions between our applications. Let's pull this over, try and get it to look a little nicer. So there's a little bit more complex interaction. So what we asked for was, I believe, web app to books. So tell me about the routes between web app and books. That's what we told Linkerd. And it gave us some information, right? And now we're looking, we asked for the routes for the web app. Now we're going to ask for the routes from web app to our authors service. And I wish I'd muted my emails as well. So here I can see, to the author service, what do we have going on? Looks like everything from the web app to authors is happening without any issue. So that's a good sign that our problem is with books or with web app somewhere, or the interaction between authors and books. So do the same thing that we asked for before, but now we want to look at when you're talking to the book service, what's happening. When we call the book service, right, most things seem to work, but posting to books.json and putting to books, whatever the ID is, .json is failing about half the time, right? So that sucks. And that sucks. And we want to find a way to, darn, little thing popped in the wrong spot. We want to find a way to resolve it, right? And just one more, we're going to ask from books to authors, what's going on, right? So we got web app to books. Now let's look books to authors. Well, books talking to authors is seeing this request to the particular author ID fail about half the time. So our problem is, right, the author service. Let me go back and show this in the UI, make it a little bit clearer. The author service, we go to our routes. Oh, right, sorry, this is the wrong window. This one's got it. Our author service. So again, if you're on that link that I sent you there, you're not going to see these profiles because the profiles are being built in a different Linkerd instance as part of a cluster. But those ones that I put in the chat, those are open and available for use anytime. But in my environment, I go look at Books app, I go check out the author service, and I click down here on my route table, right? I can see specifically what call is having the issue, right? And now I can begin to solve it. So long story short, authors fails about 50% of the time, but I know that this request here is safe to retry. So what I'm going to do, right? Maybe I got paged. It's like 2 a.m. I have intermittent failures with my author archiving service. Okay, well, I'm just going to fix it at a platform level, a platform engineer perspective. We're going to fix it, and then we're going to let the application team come in and deal with it in the morning. So what I'm going to do is I'm going to edit the service profile object, and I'm going to add in retries. And those retries are going to let me fix the issue, and I'll show you how we'll fix it and what that will look like using Linkerd routes. So here I've got my service profile object. I've got on each one, I've got the individual routes that make up that application. And my problem is here with this head authors ID JSON, right? This request fails about half the time. So okay, let's solve it right now. Well, let's solve it from a platform perspective, or band-aid it. That's a better one. Let's put on a band-aid until the morning when the actual application developers come in. I'm going to say, is retriable true? I'm going to save this change. Service profile is going to get updated. And suddenly what we're going to see is these requests are going to go from failing to succeeding. So I'm just going to watch the routes for Books app. We need to make this smaller. Can you all still see this okay? Can I get a thumbs up from folks watching chat? Okay, what we're seeing here is the success rate for this path go from about 50%, and it's slowly going to climb up to 100, right? But as that happens, I'm also seeing my latency increase, right? So it's minor, but it's going to get a bit higher. I can also add some things like, hey, let's put in a timeout to keep the latency down no matter what happens with these failures. I'm already up to 100%, so I should have moved on fast there. But we're going to now see, if I look at my other routes, we're going to see the effective success rate for these components all go to 100%, right? Which is good, right? And all we're watching now is, does the latency get too high, right? Because that's my concern now that I've addressed the failure issue. So if you're a user using my app, it might sometimes go a bit slower, but you're not going to see the thing just give you a random failure. And that is the demo. Yeah, that's the demo. I appreciate y'all taking the time to watch. If you have questions, you want to poke around, I've got the environment up and running, so we can look at things live and poke through here. And if you're interested, go check out this site to see a live Linkerd dashboard that you can mess with.
All right, thank you so much, Jason. That's
yeah. Sorry, one more plug before I go.
Yeah.
Check out, if you need it, Linkerd 2.11 getting started. If this is interesting, you want some of this in your environment, check our getting started guide and see how you can install a Linkerd service mesh in your environment in 10 minutes or less.
All right. Awesome. Okay, so I do have a question. I saw multiple numbers here on the board, the P99s and latency. Is there a way I can tie this into some kind of an SLA breach or something, so that I can use this not just to monitor, but also proactively trigger an alert or page a duty saying, hey, we're breaking the SLA, or this is happening, and we're almost there. at 90%?
Yeah, great question, right? Oh yeah, let me post the getting started link in the chat. Sorry about that. So great question. So Linkerd, the open source project Linkerd, comes with a built-in Prometheus inside the Linkerd dashboard component. You can configure that Prometheus to do a bunch of stuff. So Prometheus is a powerful tool. Linkerd is a powerful tool. You can get the data. So Linkerd's individual proxy endpoints expose data in a format that you can set up to be scraped by whatever your preferred monitoring solution is, right? And pull it in, right? And I know Datadog's got an existing integration. So if you're looking to go that route, you've got it, right? On top of this, right, the company that makes Linkerd Buoyant has a commercial extension you can put on top of Linkerd that will give you the ability to set up SLOs on your various services and set up alerting that's already obviously well integrated. But there's a ton of good options, including just using Prometheus and setting up alerting through that. Does that make sense?
That's awesome. I did see that Grafana. I was just wondering if there is something I can set up alerts there.
Yeah, no, definitely.
Oh, we can.
Right?
Okay.
And it's really easy. If you already have Prometheus and Grafana, it's really easy within Linkerd to use your externalized one. There's a ton of really good documentation on it. And if you go to the Linkerd Slack community, so let me just add that, slack.linkerd.io. Where are you? If you go here, you can join the Linkerd community. If you have questions about anything open source that you want help with, pop on in. Tons of folks there to help you. You can find me at Jason on there, and you can find a bunch of other folks as well. And looks like we've got, close to 7,000 users registered at the moment.
All right, awesome. Yeah, I see the link there as well. And one final question was regarding, so if there is a service that's not running in the cluster, let's say that I have a database that's like, running in RDS or something, and running Linkerd in, EKS. Does that kind of show any information, any debugging information that, oh, my queries are failing, or this is the latency with the database as well?
Yeah, so that's a great question. So whether or not your database is in or out of the service mesh, Linkerd is going to show you HTTP and gRPC metrics for your application. We'll give you a lot of details on that. For a connection to a database, the best you're going to get in Linkerd is just a raw TCP connection data, right? So if we look down here at some TCP metrics, you'll see again, how many connections are there, what's the data read and written, and that's it, right? Yeah, so that's that's long story. If you're off cluster, so Linkerd is a Kubernetes focused service mesh. It does not work on your RDS instance or anywhere beyond that, right? So you're not going to get TCP metrics for a connection to an external database.
Thank you so much. All right.
Yeah, and Brandon, if you want that link's available. If you go into one of these namespaces here, specifically the emoji voto one, if you click on something like the web application, sorry, Brandon asked if we could dig into the individual failing queries. So if you click on web or voting, you're going to see down here, right, as you scroll down, you'll see the live calls that are coming in to this application. Then you can do something like sort by success rate and see exactly what path in the API is being exercised and what the failure is, as well as how fast it went, how many times it's been hit, all sorts of details like that.